On April 8th, 2024, a celestial event of epic proportion will unfold. The moon will pass directly between the Earth and the Sun, casting its shadow across a narrow corridor stretching from Mexico to Maine. For those brief moments of totality, day will turn to night. The sun's corona will blaze around the dark lunar disk. Stars and planets will shine in the middle of the day, and our planet will experience some strange phenomena.
A lot of times you could have a windy day that would become very and almost eerily calm during the solar eclipse.
But this is no ordinary eclipse. The upcoming event coincides with the peak of the latest solar maximum, the most intense phase of the sun's 11-year cycle of activity. Experts say this cosmic intersection could create a unique experience here on Earth.
If there's a coronal mass ejection leaving the side of the sun, it's possible people may see an actual kind of a bulb formation.
This week, we are going off the radar and into the moon's shadow with scientists from fields like astrophysics, heliophysics, and of course, meteorology. They'll shed light on how those brief minutes of darkness can impact weather, how this solar eclipse experience may differ from the one in 2017, and exactly what you should look for when the skies go dark on April 8th. I'm meteorologist Emily Gracie, and you're listening to Off the Radar, a production of the National Weather Desk. On the show, we dig deep into topics about weather, climate, the ocean, space, and much more. Our goal is to help you better understand the weather and to love it as much as we do. Welcome to Off the Radar. Brad Souter, I have you with me today, fellow meteorologist, and I was just looking at your bio, fellow UNC Asheville alum.
Yes, is that you're an alum as well?
Yes. When did you graduate?
2006. Yes.
Okay.
And yourself?
So we were there at the same time. I graduated in 2003. You know who else went to UNC Asheville is Veronica Johnson. She's the chief at WJLA, so another UNC Asheville alum.
Small world for such a small school.
I know, right? There were like maybe 10 people in my graduating class. So.
I think I had 7 or 8.
Right. Cool. All right. So, Brad, you're on today because we're talking about the eclipse. And it's funny because we're both meteorologists. We deal with the atmosphere, but we've also been thrown into this world of space. So are you like a space junkie too? Like, I think most meteorologists kind of have this like also obsession with all things space.
Well, you know, for us, I think we got into weather because we love it. And for that sake, you know, we're looking up always, and space is sometimes out there. So anything I think that's always bigger than us always seems to kind of get me going.
And you are in the spot coming up here because the eclipse on April 8th, and you are in San Antonio. So tell me about what you guys are doing, where you're headed, and the eclipse coverage that's going to happen.
Well, what's super exciting is, you know, the eclipse begins, at least for the United States, in Texas. And in Texas, it's one of the drier paths, at least the southwestern portion of where the eclipse is coming. So really, if there's a best opportunity to not have cloud cover, would be this area of southwest Texas. There's a long path of the eclipse and a lot of great opportunities, but it's all at a risk that there's clouds. And if the clouds are there, once in a lifetime experience, you know, could be shot. So no, we've got big coverage planned. We're going to have, I think, 4 or 5 different crews out in various parts along the path. And we're anticipating a lot of people coming. Texas is a big state, and there's a lot of people to the east. There's a lot of people all over the place. So it's almost like we don't really know how many people are going to show up, but it's probably going to be a lot.
Have you experienced a total solar eclipse in totality before?
Not totality. Of course, there was the 2017 eclipse. I think I was at 97%. I was in Oklahoma at the time. Yeah, so close. I was in Oklahoma at the time. They sent me up to the Kansas border, and that was the edge of our viewing area.
Wow. Okay, so you are going to be out there covering this live, correct?
Right, exactly. Yeah, starting early in the morning, of course. I think local time, total eclipse is about 1:30 Central for us. So we're going to be doing a special afternoon program as well that will be streaming, also be live on air, and broadcasting it probably group wide. Sinclair wide, because there's a lot of interest in this, and this is kind of where it starts. And so other people that are farther north can see what's coming their way.
Yeah, we're actually going to do some national coverage. We're going to be hitting up our Sinclair stations all throughout the past. So we're going to use you. You're going to be one of the first live shots we use with the National Weather Desk, and we're going to be streaming that live. So that'll be a lot of fun to kind of check in with all the meteorologists throughout the path of totality.
I think there's just so much. I'm looking forward to all the scientists that Sinclair has prepared to be out there with us to talk about this, their perspectives, their experience, when to see that right moment when the jewel of the edge of when it's the moon is moving back away occurs, and all the solar flares. And I'm just going to try and come up with a list of things I want to accomplish in that 4.5 minutes. I really want to people watch too, and just experience what others are seeing, because everybody has a different experience, and people describe it as something that they've never experienced before. People cry. They have moments of total elation. And I think any time that you can look up and appreciate something outside of our phone and outside of our normal world, it just reminds us of who we are and how fragile the planet is and how things can change. So I can't wait.
Awesome. Yeah. Speaking of scientists, today's show has a lineup of really good scientists, and one of them really talks about that cloud cover. He's a meteorologist, and he talks about a weather forecast tool that he created that takes into account the eclipse and those moments of darkness on the weather. And they have found that tends to be a clearing of clouds when it does get darker because of the cooling temperatures. So the clouds tend to break up a little bit, which is good news for viewing. But then I'm also going to talk to a space weather forecaster about this elevated solar activity that we're in right now and how that could impact our viewing for the eclipse. We may see some different things compared to the 2017. And then I'm also talking to a solar photographer. A lot of people photograph at night, but this guy, he photographs during the day, and he takes pictures of the sun that are amazing, and it really helps you appreciate our star in a way that is just unbelievable when you look at these images. So, Brad, we're so excited that you're going to be out there covering this for us, and wish you the best and wish you clear skies. It's also weather dependent, but I appreciate you coming on to chat with us a little bit about this today.
Well, thank you, Emily.
The first expert we're going to hear from today is Heather Futrell. She's a program executive in NASA's heliophysics division. For those who don't know, heliophysics is the study of our sun. Heather's going to help answer some common questions about the upcoming eclipse, including clearing up any confusion when it comes to the difference between being in the path of totality versus being just outside that path. If you're in that path of 100%, great. What if you're in the path of 90%? I've heard people say there's a huge difference between that and totality.
Yeah, so if you're in a partial eclipse, you definitely need to make sure that you're wearing glasses or you're indirectly viewing the eclipse at all times. You will still see how the sun changes shape as the moon crosses through. So you'll see kind of different crescent shapes of the sun kind of poking around the moon. So you just won't have that full 100% obscurity where the moon is fully blocking the sun unless you're in that path of totality. So depending upon what percentage of partial you have, you will still see, the sunlight will decrease a little bit. Some of the temperatures may cool down a little bit, but it won't be nearly as much as you would experience if you were in the path of totality.
I know that you can take off the safety glasses when you're in that couple of minutes or whatever of totality. How do you know when you're in that time period and if it's safe to take off the glasses and look up?
Right. So what happens is that when you're looking through the glasses, you actually won't see anything at totality because the sun is completely blocked. So that's when you'll know, I should take them off if I want to see something.
What about Bailey's beads? Can you explain what those are and if we're going to see those?
Yeah, so the Bailey's beads actually will show kind of right before you get into totality, and then you'll see it again too upon exit from totality. And so what that is it's the last rays of the sunlight that are going through the topography on the moon's surface. So it's kind of going through the last valleys and things of the moon, and that's what kind of creates a few little dots of beads.
It gives me goosebumps thinking about that. That's very cool.
Holy photo labs, yeah.
Many of us experienced the total solar eclipse in 2017, but something has changed since then, our solar activity. I have some questions about what that might mean for this eclipse. So I reached out to Sean Dahl from NOAA's Space Weather Prediction Center to get some answers. Okay, so everybody's talking about the eclipse coming up here. And we had an eclipse a few years ago, but we weren't in this kind of higher activity. So is there going to be a difference with this eclipse? Are we, as just people on Earth looking up at the eclipse, going to notice anything different from versus the 2017 eclipse to this eclipse because of this higher activity?
We could get really lucky during this long eclipse. And that's the only safe time, I should stress, that you can actually look at the sun unprotected is when it's totally covered up. And the corona, that's the first thing people could take witness of, is that outermost layer of the sun where the solar wind is now streaming into space. And you can see this lovely corona. It may have some structure and shape instead of just a nice circle this time because of solar max. There's going to be changes there. People, if there's a coronal mass ejection leaving the side of the sun, it's possible people may see an actual kind of a bulb formation along the perimeter of the moon there in the inner solar corona. Also, one area of the sun that's kind of between the area that the light escapes, called the photosphere, and the corona is one called the chromosphere. And you can see that as a little red color right around the perimeter of the moon, or just as it's gotten covered up. And you may see a large filament, this fiery orange, red colored thing, if there's one happens to be attached to the side of the sun, if you will, in a magnetic field. That'd be pretty cool to see too. Another thing people can look for during the solar eclipse are the source of a lot of these storms, and that's sunspots. Now, you can only do that if you have a safe viewing solar filter for your eyes. That's the only way you can do that without going blind and hurting yourself. But we've been having some pretty large sunspot groups in the sun as of late that have produced the source of a lot of this activity we've been talking about. So as we continue to go throughout the year, the presence of this type of activity and the chances it's going to continue are still straightforward for the next several years, really.
Yeah, that raises a good question of we all have these glasses and we're using them for the eclipse. Can we use them outside of the eclipse to view the sun? Is that safe? And if so, is there anything we can actually see with them?
Yes, as long as it's the safe viewing for your eyes, solar eclipse glasses, and they're certified, ones. I would recommend the American Astronomical Society has a list of those that they deem safe. But yes, you can use those. You could go out right now if the sun is shining, if you have those glasses, and see if you could see any of the larger sunspot groups that are already sitting on the sun for us in our view.
All right, so now we have a good feel for what's going to happen with the sun and the moon on eclipse day and how we should prepare when looking up. But there's a lot going on that will be happening here on Earth too. I think we all know that when it gets dark, it generally gets cooler, right? But there's a lot more at play here when it comes to the weather and nature here on Earth during an eclipse. So for that, I'm turning to Josh Wise, a forecaster at the Weather Prediction Center. Josh developed a special forecast tool that takes the eclipse into account for temperature forecasts in that path of totality. Can you tell me, first of all, what is going to happen to the temperature in these areas of totality on April 8th?
It's really fascinating what happens to the temperature during a total solar eclipse. In this case, the solar eclipse is going to happen, late morning, early afternoon across the country when you would expect temperatures to be at the hottest part of the day. But actually what will happen is temperatures will drop during the eclipse. We've seen a lot of data over the past couple of eclipses that show approximately 30 to 45 minutes before totality, you will start to experience a drop in temperature, and it will be noticeable by the time you get to totality because now you're basically at nighttime. There is no more incoming solar radiation. The temperatures will drop and you will feel like you're late evening, even though it's going to be like 1 or 2 o'clock in the afternoon. So it's going to be noticeably chilly, and you can get temperature drops. From 2017, we saw the temperature drop between 4 and 10 degrees Fahrenheit. And actually, there have been some reports of drops as much as 16 degrees Fahrenheit from other total solar eclipses. So it will be noticeably chilly during the eclipse, but then after the eclipse starts to wind down, it will warm right back up to those typical, in this case, April temperatures.
How do you forecast this? I know that when you're forecasting daytime highs, generally, you're looking at years and years of computer model data and old data. So something so specific as this one day where we don't have a whole lot of historical data, how do you forecast that change in temperature?
It is a fun challenge, is the way I will put it, from the National Weather Service perspective. The National Weather Service has a responsibility to accurately forecast hourly temperatures across the country. We have partners that rely on that temperature data for whatever they need. So even though it's only an hour or two of a temperature drop, it is still important that we forecast it. So what we have done, starting with the 2017 eclipse, is cooperatively, we developed a forecast tool in our what we call our graphical forecast editor, which is the computer software we use to create our forecasts. And we developed an algorithm from the 2017 eclipse that allows us to hopefully accurately forecast a temperature reduction that will occur, plus 1 hour to minus 1 hour around totality for the areas that will be experiencing the total eclipse. And that temperature reduction is not simply due to the solar eclipse, but also the amount of cloud cover that day, the relative humidity that day, and maybe the most important is kind of your typical, what we call our typical diurnal temperature curve that day, which is kind of like the minimum temperature and the average high temperature for that day. We put all those together into this tool that we developed, and it will hopefully allow us to accurately forecast the temperature reduction that will occur in areas that receive the total solar eclipse.
Interesting. So this was used already in 2017?
That's correct. Yeah, we first developed this for the 2017 eclipse, and it was used heavily across the Southeast United States. If you remember, that eclipse went from Oregon to South Carolina, went across the entire country, and we had really good verification. It was forecasting generally a 4 to 8 degree temperature drop, and a lot of the verification we did was about 4 to 8 degrees. So we have some good verification. This tool does a good job of forecasting that very anomalous change in temperature, reduction in temperature during the afternoon.
And so many things that are impacted by temperature as well, not just like that actual feels like, but like storms could be impacted, right? Like cloud development. This is like touching every little part of weather, right?
Yeah, you're absolutely right. I think the most fascinating thing, at least for me personally, and a lot of my fellow meteorologists that I spoke to, that we observed in the 2017 eclipse was how quickly the cloud cover dissipated during the eclipse. I think we all kind of expected that there would be some reduction in cloud cover, but it went in some places from, almost thunderstorm-like clouds to clear sky conditions during totality. Those clouds evaporated very quickly, which for some people saved them in the eclipse because they were there. It started to get cloudy. I was one of those people. I was in upstate South Carolina. I saw all the clouds building and I was a little nervous. But those clouds really eroded. We ended up with a perfect viewing of totality. And I think that was one of the most interesting observations we made during 2017 was just how amazing the cloud reduction was during the eclipse. So if you are in an area that maybe receives thunderstorms frequently in April, this day might be relatively quiet because the sun is the major player in our weather. It's the factor that drives our weather. So if you cut the sun out of the equation, you're going to be unable to get that active weather. And hopefully a lot of us will see the eclipse that day.
Oh, that's so interesting because that happened to me too. I was in Charleston, South Carolina, and it was cloudy, and we were very disappointed. And then shortly before totality, the clouds cleared and we had a great view of the eclipse, and it was amazing. There were storms kind of happening around us. Okay, so what else is impacted by like these minutes of darkness and this drop in temperature? Is there anything else around us we should be looking for or listening for or feeling for?
Yeah, absolutely. There's so much that occurs during a totally solar eclipse. It really is in this case, twice in a lifetime opportunity for us to experience, but it's something I hope everybody gets the opportunity to do. From the meteorological perspective, not only do the temperatures drop and the cloud cover erodes, but the relative humidity will surge during that time. And actually, there have been some observations of fog developing in the middle of the afternoon because the temperatures drop, which, if you know anything about fog, it's usually kind of a morning phenomena when the relative humidity is highest. You can get some shallow fog during that time. The other thing is without the sun mixing the atmosphere, the winds will drop. And a lot of times you could have a windy day that will become very and almost eerily calm during the solar eclipse. From the weather side, those are the most fascinating things to observe. But just from the broad scale of eclipses, there's so much other things that are going on. One of the things that I think was most fascinating is how the animals, they'll start to think it's nighttime. You'll see birds going back to roost. You might hear some of the nocturnal creatures come out for a few minutes. So that is really fascinating to observe. The sky during totality, it's almost like a really weird looking dusk. It's not pitch black. It's not dusk. You'll see like a weird ring of light around the horizon where it's not fully covered by totality. But, I know this is a little bit of a philosophical comment here, but I think just observing the people around you is really fascinating to watch because everybody's just in awe of that moment of totality because it's not something we see very often. And I've seen people cry. I've seen people, yell out and whoop in excitement, and just observing the people around you is almost as exciting and just as rewarding as observing the weather and natural phenomena that are occurring at the same time.
Okay, so Josh, this is all stuff that we're going to see kind of in front of us and on the ground. Is there anything that's going to be picked up on weather radar or satellite that we can look for when it comes to the eclipse?
As far as the satellite goes, we will absolutely see the shadow crossing the country. We will likely see the clouds dissipate, and we will also see that penumbral shadow going across the country. From radar perspective, it's really interesting because I mentioned earlier, the birds will kind of go home to roost, as they say, and our radars are sophisticated enough where they can identify the difference between birds, insects, and rain. And we may actually see the birds returning to their homes at a weird time of day. Now, something we see frequently in the morning is the birds leaving to go hunting in the morning, but we may actually be able to identify the birds returning back to their homes or their nests during the total eclipse. And that's because of our what we call our dual polarization radar, which can help us identify birds and insects versus real radar returns like rain and hail and snow. So that'll be another interesting observation from the meteorological side to really observe and see if we can see that happening during the total solar eclipse.
I'd like to finish this episode with some words from a solar photographer that I spoke to recently. Shannon Norton took a time lapse of the sun that went viral. In fact, it was so detailed, some people questioned if it was real. I asked Shannon why he shoots the sun. Why this when there are so many other celestial objects out there? First, he told me it was mainly because he could do it during the day rather than staying up all night. But he also shared this.
The sun's my happy place. It's the only thing in the sky that you can look at half an hour later and it can look completely different. You know, all the planets, the nebulae, the galaxies, everything in the sky, they look identical because they're so far away. You can look at it every 2 years and it looks exactly the same, but I can come inside, have a coffee, go back outside and look in my telescope again and the sun can look completely different. It's the only thing we look at with our telescopes that's changing so much.
Have you learned anything by watching the sun? Anything that really surprised you?
The very first time I imaged the sun, I counted the pixels of the sun and got a picture of a black dot of Earth and I put it next to it with a scale, and I was blown away when I actually realized how big the sun is compared to us. If anything, watching the sun just makes me feel a little bit insignificant, I guess. There's so much more out there that's a lot bigger than us, I should say.
If you want to check out that amazing solar time lapse, head over to our YouTube channel. Just search the National Weather Desk and you'll find it under our Caught on Camera playlist. While you're there, hit the subscribe button. That way you'll be alerted when new videos are posted. You'll also want to check out our YouTube channel on Eclipse Day because we'll be streaming a live 3-hour special hosted by myself and meteorologist Veronica Johnson. We'll have live updates from dozens of reporters in that path of totality, and we'll be monitoring the weather, of course, in that path during the eclipse. Off the Radar is a production of the National Weather Desk. Make sure you're following the show on Apple Podcasts, Spotify, or wherever you listen to podcasts. New episodes publish every Tuesday. If you know someone interested in the eclipse, the sun, or space in general, please share this episode with them. We'd also love you to rate and review us on Apple Podcasts and Spotify. Let us know what you think of the show and give me some ideas for future episodes. Big thanks to my guests today, Heather Futrell, Sean Dahl, Josh Weiss, Shannon Norton, and to Brad Souter for joining me at the beginning of the episode. I'm meteorologist Emily Gracie. Make it a great day.